Okay, first one, we're doing 2x minus 1 less than 3 minus x. So first thing to do is sketch both curves. So graph mode, we want modulus options, numeric abs, 2x minus 1, and modulus 3 minus x. Let's check the V window. Make sure. Ah, the wrong minus there, haven't I? Oh, that's better. Okay, so blue is this one, red is this one. So we can see if I zoom out a little bit, you can see that blue is less than red between those two numbers. So we need to find those two numbers first of all. Well, two intersections, so two ways of doing it. Well, if you look, the blue one, it's on the, this one here is on the negative side, and the red one is on the positive side. So to solve them, let's just do, imagine we don't need the moduluses for both of them. So we get, take the x outside, 3x, plus 1 to both sides, divide by 3. So we get x is 4, 3, that's 1. And now for another answer, there's no point in making both of them negative at the same time, because I can just times both of them by minus 1. So I'm just going to make one of them a minus. So 2x minus 1 is minus 3 minus x. Get rid of the minus bracket, so minus 3 plus x. Take the x to that side, plus to that side. So there we go. There's my two answers. So I'm just going to check on here. So I'm going to go on GSOL, intersect. They got x is minus 2, and 1.3 recurrent is 4/3. So we want when blue is less than red. So minus 2 less than x less than 4/3. You could always kind of do the number line approach and pick 3 numbers and see which regions work. So if I pick a number in the middle, so 0, and sub 0 into there, I'll get modulus of minus 1, which is 1, modulus of 3, which is 3, and 1 is less than 3, so 0 did work. So the middle is my inequality I'm looking for. Yeah, it's obviously easy if you've got a calculator. Second one. So find the equation of the normal to the curve that, well, 3 equals, I'm going to rewrite it as that, with minus 1 is the power. And we know that x is 1, so straight away I'm going to sub in x is 1 into there to get y is 3 over 2. Now I'm just going to show you so you can do in your calculator. So on graph mode, x to that, and delete both of them. So if you go into shift and setup, go down to where it is derivative and make sure that it is on. Now when I draw this graph, so 3 over x cubed at 1. So when I draw that graph, if I click on sketch, there should be some options. Now if you see this tangent and normal, so if I click normal, and I go along to x equals 1, so x equals 1 there, it's giving me what dy by dx is. So ignore dy by dx, just imagine that is m. So it's giving me that m is minus 2.25. It's giving me what y is, 1.5, which is 3 over 2. So I've got all the numbers I need to work out the equation. So I could do it straight away now. But to get the marks though, we need to show that m is minus 2.25. So to do that, we differentiate. So dy by dx. I'm going to ignore the 3, leave it alone. I'm going to differentiate this. So I'm going to bring the minus 1 to the front, so make that minus 3. Take away 1 to the power. I need times by the derivative of that, remember, which is 3x squared. So that gives me minus 9x squared times x cubed plus 1 to the minus 2. I'm going to sub in x is 1, so I get dy by dx is, I sub in 1, I get minus 9 times 1 over 4, so minus 9 over 4. But it's normal, and you do negative reciprocal, so 4 over 9. So I can sub it into y minus y1, so y minus 3 over 2 is 4 over 9, x minus 1. I'm going to times both sides by, I'm going to do 18 together with a 2 and a 9. So 18y, take away, if I times this by 18, the 18 and the 2 will make a 9. 9 times 3 is 27. If I times this by 18, I get 2. 18 over 9 is 2. So 2 times 4 is 8. So 8x minus 8. Take everything to one side. So 8x minus 18y plus 27 onto there gives me plus 19 equals 0. Or rearrange to get y equals to 1. So y would equal 8 over 18x plus 19 over 18. And that would simplify to give us 4 over 9. Yeah, but that calculator trick was quite nice. Yeah, get x is 1, y is 1.5, and it gives you what n is as well. So it gives you all the numbers to do this. You can still get some marks, even if you can't work out where that comes from. Oh, it's a good check as well. Okay, third one. So 5x plus 1 over x cubed plus x squared. We want that in partial fractions. So the bottom needs to be factorized. So I can factorize out an x squared. And I'm left with an x plus 1. Okay, next thing to check is an improper fraction. Well, the degree on the bottom was 3. The degree on the top is 1, so it's not. It's a proper fraction. So I'm going to have a over x squared plus b over x plus 1. But here, look, I've got a repeated factor, got an x squared, so I need to have just a c over 1x. Okay, so times it by the bottom, so 5x out of 1 is a lots of x plus 1, plus b lots of x squared, plus c lots of, for the x, will cancel out one of those x's, so x and x plus 1. Sub in your magic numbers, so 0. So I've got 1 equals, that disappears, so 1a. So nice and easy. Second magic number would be minus 1. So minus 5 plus 1 is minus 4. Equals, that disappears, minus 1 squared is 1. So I just get b. So b is minus 4. Now I need another random number, so I'm going to choose just 1. So I get 6 equals 2a plus 1b plus 2 times 1 is 2c. Sub the numbers in, so 2 minus 4 plus 2c. So minus 2, that gives me 8 equals 2c. So c equals 4. So we get A is 1, b is minus 4. So actually, I'm going to write that minus 4 of that, and that's 4. Fourth one. So 4 rectangles of equal width. Find lower and upper bounds for 1 to 2 of 1 over x cubed add 1. Okay, well, first we'll work out what the height of the rectangle is going to be. 2 take for 1 over 4, so that's 0.25. Now we need a table going up in 0.25s. So start at 1, so 1.25, 1.5, 1.75, 2. Let's use 3 decimal places again. So go on to table. It's 1 over x cubed and 1 set 1 to 2, 0.25. So there's our answers: 0.5, 0.339, 0.229, 0.157, and 0.111. Okay, I'm going to sketch that curve just so I can see which one's going to give me the upper and lower. The window, I'm going to change the scale so it goes between 1 and 2, 4, and it looks like it's going down like that. So it looks like if I start with the first one, I'm going to get rectangles being above, so I'm going to get an overestimate of 3 rectangles one direction. So if I use these 4 numbers, I get my overestimate, and if I use these 4, I get the underestimate. So these 4 will give me the upper bound, these 4 will give me the lower bound. So upper bound is h times these 4 added together, which gives me 0.31 to 2 decimal places. Lower bound is these 4 together, 339 plus 0.229 plus 0.157 plus 0.111, and that gives me 0.21. So I know that the area, I missed my dx there as well, is less than 0.31, bigger than 0.21. Now I'm just going to check, and if I zoom out, I'm going to show you how to check on here. So if I go into the G-solve and go along, there's an integral button. So if I start at, it's not going to go on 1 nicely, is it? Then lower bound as 1. And upper bound as 2. So the area is 0.2543, so it is in the middle. Okay, and last one. So we've got displacement is given by x equals 5 sine 3t plus t cubed. Now we want the acceleration when t is 4. Okay, well, to find that, we're going to go down dVA, so we're going to differentiate. I'm using dVA look because it's definitely variable. So v equals differentiate, so sine goes to cos. I have to times by the root, so times by 3 is like 15, and that goes to 3t squared. Differentiate again, so sine goes to cos goes to minus sine, times by the derivative, so it's 3, so 45. That gives me 60. Sub in t is 4, so make sure you're in radians, and we get equals 48.1 meters per second squared, 3 significant figures.